Hello friends, welcome to the online lecture series of Basics of Computer. Myself, Assistant Professor Mr. V.R. Vadekar from Department of Electronics and Telecommunication of Matoshi College of Engineering and Research Center, Nasik. We are studying unit number 1 and we are towards the end of this unit, that is data communication and network models. But before starting our today's lecture, let's have a quick revision what we have studied in our previous lecture. Students, in our previous lecture, we have studied about transmission impairment. That is, the signal that we are going to send from one end of the transmission medium and what we receive at the other end is totally different due to your distortion, due to noise, due to attenuation. And we studied each one. After that, we have studied about shunt capacity theorem, what is Nyquist bit rate for noiseless channel, and for noisy channel we studied about shunt capacity theorem. Then we solved few numericals in order to understand that, and then we discussed the performance of the network. So let's have a today's topic. Guys, today we are going to study one of the important topic, that is OSI model. Nothing but your open system interconnect model. But before that, guys, as we know, a network, it uses a combination of hardware and software, to send the data from one location to another. Hardware, it consists of a physical equipment that carries a signal from one point to the another point. And what we expect, the services that we expect from the network, it is much more complex than just sending a signal from one computer to another computer. Suppose if we want to solve any mathematical problem with a computer, then the fundamental job of solving this problem in a computer, it is done by computer hardware only. But it would be, very complicated and complex task if we are going to use just a hardware. Because in order to, change the program, manipulate the data storage, we required a lots of, switches for this every memory locations. And this task, it would be very much easier if we are going to use the software. Suppose you are going to send email to someone, then how this task, it has been broken, into several subtasks, each performed by some software packages. And each piece of software, it is going to use the services of another software to just send a mail. So guys, in our daily life, we use the concept of layers. So suppose we would take an example, the two friends are there who are going to communicate through postal email, not electronic mail, it is a postal mail. And the process of sending the letter by means of the sender to this receiver to his friends, it would be very, very much complex if the services from the post office, it is not there. So let's start that how the letter it has been, sent from sender to receiver. So at the sender side, what we have divided this task into 3 layers: higher layers, middle layers, and lower layers. So if you can see at the sender side, at higher layer, the sender, it is going to write the letter. First, what we have to do we have to write the letter, right? Then what we do, after writing a letter, we are going to insert the letter in an envelope. And after inserting the letter, what we required, definitely we required to, write the sender and the receiver addresses. Because without that, you couldn't send a, letter to your friend or anyone. And then we are going to drop that letter in your mailbox. That is the duties of your higher layers. Now your task is over. Now you are going to use the services of middle layer. Now how it is seen. At this layer, the letter, it is a pickup by this letter carrier and delivered to the post office. And at the lower layer, the letter, it is sorted at the post office, whether this letter belongs to, which region, whether it is Maharashtra, it is out of Maharashtra, within Maharashtra, which place, which district. So every, the sorting, it has been done. And after the sorting, then we fix that transport, and then the carrier, it is going to transport the letter. So this operation, it happened at your sender side. Now once the letter, it is delivered to a carrier by the post office, now what would happen on the way? This is the on the way. So then later it is then on its way to the recipient. And on the way to the recipient local post office, it may actually go through, central office. And this transmission, it could be, by truck, by train, aeroplane, boat, or combination. So once it has been received at the receiver, now first the letter, it has been, picked by the lower layers. That is the carrier, it is going to transport the letter to the post office of the recipient address. Then over here, the letter, it is assorted that which location, which area it is there. Then depending on that, what is the pin code, then it is delivered to the mailbox of the recipient. And when the letter, it has been dropped to the mailbox of the receiver, then this letter, it is picked up by his friends and then removed from that envelope, and it sees who is the sender, and then it is going to read the letter. So daily, guys, we are going to use a concept of this layered task. So now after understanding this layered model, now we would study about your OSI model. Now guys, in 1947, ISO is being established. ISO, it means International Organization for Standardization. It is nothing but your multifunctional body, which is dedicated to worldwide agreement on international standards. So, an ISO standard, it is going to cover all the aspects of network communication. It is nothing but your OSI model, that is Open System Interconnect. So just keep in your mind the difference. ISO, it is the organization, and OSI, it is the model. So don't get confused between OSI and ISO. Now this name Open System Interconnect, it has been given. Why? Because an open system means it is a set of protocols that allows, any two different systems from different vendors or manufacturers to communicate regardless of their architecture. Whoever may be the vendor, whoever may be the manufacturer, it is there. But it is a set of protocols that allow these two different systems to communicate. Without requiring any changes to the logic of this, the underlying hardware or software. So OSI, it is not just, it is a protocol. It is a model for understanding and designing a network architecture that is flexible, robust, and interoperable. So you can see on the figure that OSI model, it is a layered framework for the design of network system that allows communication between all types of computer system. So you can see on the figure that it consists of 7 layers, and each of which, it is going to define a part of some different functions in order to move information. So first layer, it is what? Your physical layer. So now we would see that what is the function of physical layer one by one. So, but before that one, you can see that how the interaction between layers in the OSI model, it has been taken place. So just before getting to the each layers, just you have a quick view that suppose device A, it is going to communicate with device B, but in between them, definitely you required some intermediate nodes. That could be your switch, that could be your router. So we have assumed it as a router over here. So you can see that device A, it consists of 7 layers. Device B, it consists of 7 layers. But the intermediate nodes, it consists of only 3 layers, or it may happen it consists of 2 layers only. As like your switch, it requires only 2 layers, that is physical and data link. Since it is a router, we have also added a third layer, network layer. So for these intermediate guys, these rest of the layers like transport, session, presentation, application, they won't required. So that's why we are not going to make it a complicated for those intermediate nodes. So minimum layers what we required. So due to which, the complication, the cost, it is also get effective. Why to use these 7 layers for intermediate nodes? So you can see that one, that how they are communicate each layer. Now, also, this is the basic concept in the OSI model that we are going to use. Now you can see on the figure. Suppose this computer, it has a data which is called a D7. So encapsulation with header. It means you can take any examples in your medicines. Maybe you have seen a capsules. In that capsule, what is there? Some medicine, granules are there. Tiny granules are there. And those tiny granules are packed in that capsule. So similarly, the data, it is encapsulated with this header. Right? So, definitely this header, it has some information. So when this data from this upper layer, higher layer, that is the 7th layer, it comes to this 6th layer. So you can see that one over here, that it becomes a D6. It means your D6 is equal to H7 plus D7. Now, at this 6th layer, again this 6th layer, it is going to add this header, that is H6. So now it is H6 plus D6. It is goes to the lower layer, that is to the 5th layer, and it becomes a D5. That is your data. It means D5 is equal to H6 plus D6. So you can see that each layer, the encapsulation, it is going on. And more important thing, you can observe the difference that at the 2nd layer, that is at the data link layer, along with this encapsulation with the header, it is also going to do it encapsulation with the trailer. Now, this trailer, it would give you, it is basically used for error detection purpose. So that's why it is being added to your data. But it is, remember, it is done by only the 2nd layer, that is your data link layer. So after that, at the physical layer, at the bottommost layer, this 2 plus H2, it becomes, it consists of a bits, and physically it is also going to do the encapsulation. And these bits, these are then transmitted through this transmission medium. And at the receiver side, this is your receiver side, this is your sender side. So at the receiver side, these bits, see how the decapsulation process it goes on. It has, at the sender encapsulation, it has been over. It has been done. But at the receiver, decapsulation, it is being done so that you can receive your original data D7, what we transmit by the sender. So the process of adding headers, it is encapsulation, and the process of removing those headers and trailers, it is nothing but your decapsulation. So hope so you understood how the data it has been, transmitted using this OSI model. Now guys, let's start with the first layer, that is physical layer. Now physical layer, it is responsible for the movements of individual bits from one hop, from one node to the next node. Hop in the sense, guys, node over here, just next to next. It is going to specify the mechanical and electrical, the procedures, the functions of those hardware equipments. So you can see it over here, that the data it is coming from the higher layer, that is a data link layer, and this is your physical layer. So it is responsible for movement of these bits from one hop to another hop, and this is your receiver side. Now, what are the duties? What are the functions? First is physical characteristic of your interfaces and media. It means it is going to define the characteristic of the interface between the device and the transmission media. Even it is also going to define the type of the transmission media, whether it is a coaxial cable, UTP cable, fiber optic cable, like that one. The second duty, it is your representation of bits. As we know that physical layer, it consists of what? Stream of bits. So in order to be transmitted, bits must be encoded into signals, whether it could be electrical or optical. So physical layer, it is going to define the type of representation, that how 0 and 1s are changed to signals. Next, data rate. That is your transmission rate. The number of bits it is transmitted per second. It is going to define the duration of the bit, how long it lasts. Then synchronization of bit. Remember guys, the sender and receiver not only must use the same bit rate, but also must be synchronized at bit level. If the sender and the receiver clocks are not synchronized, the receiver may interpret the data in a wrong manner, that 0 it is interpreted as 1, 1 it is interpreted as 0, like this one. And then your line configuration and the physical topology. Whether in line configuration, whether there is a transmission of a data from a sender to only one receiver, which is a point-to-point communication, or whether it is going to send the data from a source to many stations, many receivers, that is multi-point communication. Next, it is your physical topology. Physical topology in which how physically the network it has been laid out, whether it is a star topology, whether it is a ring topology, or it is a hybrid topology, bus topology. So all these are the duties of your physical layer. And then your transmission mode. Transmission mode in the sense whether your communication it is a simplex, that is just a sender it is going to send the data, as like your radio or television system, or it is a half duplex, that the transmission and reception both are there, but not simultaneously, as like your walkie-talkie. Or it is could be full duplex. That is both sender and can receiver send and receive the data simultaneously. Next is your data link layer. So the data link layer, it is responsible for moving frames from one hop to next. Remember hop. The data present at data link layer, it is called frames. So just remember, guys. So see, from a network layer, it is going to receive the data, and this is your data link layer. And below the data link layer, it is your what? Physical layer. So you can see it over here. Along with header, it is also going to add the header, and this is done by this data link layer only. It makes the physical layer error free, to the upper layer, that is network layer. Now, we would see the duties of data link layer. It is your framing. The data link layer, it is going to divide the stream of bits received from the network layer into manageable data units called frames and physical addressing. Now, if frames are to be distributed to a different systems on the network, then data link layer adds a header to the frame. Now you would come to know what is there in that header. So in that header, it is going to define the address of the sender and the receiver. So if that address it is going to match with that receiver, it is going to accept the data. Otherwise, it is not, it is going to reject the data. And this physical address, it is also called as Ethernet address or MAC address. Next, it is your flow control. Now, flow control means if the rate, at which the data are absorbed by the receiver is less than the rate produced in the sender, then definitely we need to impose a flow control mechanism in order to prevent, overwhelming of the receiver. Otherwise, what is going to be happen? Sender, it is going to send the data at the 10 Mbps rate, whereas receiver has the capacity of receiving the data at only 5 Mbps. So what about the rest of the data? It has been lost. Next, it is your error control. Now guys, this data link layer, it is going to add the reliability to the physical layer by adding, mechanism to detect and retransmit your damaged or lost frames. For that purpose, we are going to use a trailer which is added to the end of the frame that I told earlier. Now, last it is your access control. Now, when two or more devices, they are going to connect it to the same link, the data link layer protocols are necessary to determine which device has a control, over the link at any given time. And remember, data link layer, it is responsible for hop to hop delivery, that is node to node delivery. So you can see it over here. A node A wants to send its data, suppose, to end system F. So the address which is present in that frame, it is going to tell you the sender address as well as the address of the receiver. So you can see that the data, first it is given to this intermediate system B. It is a switch, so it consists of a two layers, suppose physical and data link layer. Now it is going to read that frame. Then it got the idea, yes, its destination, it is F. Then to which link should I transmit? Through this link or through this link? So it is a calculation done by this intermediate nodes. Then it is going to send the data through this link and it is received by this intermediate system, that it could be switch or router, by E. E again, it is going to see to which next intermediate node, or through which link should I send the data so that it could be easily received by the F. It then calculates the path and it is going to deliver it to this one. So it means hop to hop delivery it is there. Understood? That is node to node delivery. Now, the next layer, it is called a network layer. Network layer, it is responsible for the delivery of a packets from source host to the destination host. Now, this layer, it is not looking for hop to hop delivery. It is going to see the directly, from source to end delivery. And the data present at this layer, it is called packets. Remember. So from the transport layer, network layer, it receives the data and makes the encapsulation and give it to the lower layer, that is your data link layer. Now, what are the different duties of network layer? Now, when if two systems are connected to the same link, there is no need for this network layer. It means if you are going to send the data within a network, then no need of this network layer, but just by using a data link layer, you can send the data. But if two stations are connected to different networks, then we require this layer, network layer. And for that we require the IP address, logical address. So logical address, the physical address, remember, it is implemented by data link layer, whereas the logical address, it is handled by this network layer. If address problem, you need to handle the address problem locally, you require the data link layer. But if your packet, if your data, it is going to cross your network boundary, then you require another addressing, which is called a logical addressing or IP addressing. And you can see that in previous figure you have seen, it is going to add the header. So this header, it is going to contain the address, that is a logical address, IP address of the sender and the receiver. And next it is your routing. So when independent networks are connected to create a internetworks, that is a large network, the connecting devices called routers, or it could be switches, they are going to route or switch the packets to their final destination. So end to end delivery, that is A to F, it is being undertaken by which layer? Network layer. It is not going to look upon the hop to hop delivery. For hop to hop delivery, data link layer it is there, but for source to destination delivery, network layer it is there. Now the transport layer is responsible for delivery of a message from one process to another process. Whereas the network layer, it is oversees to host to destination delivery of individual packets. It doesn't recognize any relationship between those packets. It is going to treat each packet individual as a independently. But the transport layer, on the other hand, it ensures that whole message, it is going to arrive intact and in order. Which is going to oversee both error control and flow control, but at the process to process delivery level, not a hop to hop level. So this is the difference. So you can see it at the transport layer also, encapsulation it is there. It means it is going to add the port address. Now, service point or port addressing. Guys, I want to, take one analogy that you can understand this port addressing. Suppose your friend, it is going to write your letter. Person A, it is going to write a letter to person B. But it may happen the person B, it is living with his all family members. Right? Although the family members and that friend B, it has the same address because they are living in the same home, in a family. So when the address, it is being found by where your friend B, it lives, we are going to, hand over this letter or parcel to that address of that B. But it is not necessary that person B only receive that packet or letter. It may happen on behalf of him, his mother, his father, his cousins, they are going to, receive that parcel. So port addressing, it is going to deliver, it is going to take care that that parcel, that letter, it should be handed over to that person B only. So similarly, guys, computers, are running several programs at the same time. At the same time, you are watching online music, videos, you are downloading something, you are chatting with someone, or you are surfing the web. So many functions are there. Behind that calculation, it is going on, right? So for this reason, the process to process delivery means delivery not only from one computer to next, but also from a specific process on one computer to a specific process on the other hand. If I am going to send a mail to anyone, so it must be received by its, mailbox only. So the transport layer, it is going to, header. Therefore, it includes a type of address which is called that port address. Next, it is your segmentation and reassembly. A message is divided into transmittable segments, and each segment, it contains a sequence number. And due to these sequence number, it enables, transport layer to reassemble the message correctly upon arrival at the destination. Because suppose a message is divided into 5 segments, 1, 2, 3, 4, 5, and at the receiver second segment it has been received, then first, then fifth, then fourth, then how that receiver would come to know how to make this message intact in a sequential manner. So for that purpose, these numbers, it is going to help the receiver for reassembly purpose. Next, it is your connection control. Guys, the connection, it could be connectionless or it could be connection oriented. Connectionless means you can send each segment as an independent, packet and deliver to the transport layer at the destination. So it is not necessary that all the packets of those segment, it is going to follow the same route or path. Although the message, it is the same, but their packets, they are going to follow the different routes. That is a connectionless. But in connection oriented, before transmitting those packets, the path is fixed that you have to go through this path only, through this switch or router only. then all the packets of those segments, they are going to follow the same paths. So depending on the nature of the traffic, depending on the number of hops, it is going to decide that whether it could be connection oriented or it could be connectionless. Now, next it is your flow control. Like the data link layer, the transport layer, it is also responsible for flow control. But remember, this flow control is performed end to end rather than hop to hop or across a single link. And last, it is the error control. Like the data link layer, transport layer, it is also responsible for error control. But this error control at this layer, it is performed end to end rather than single link or hop to hop. So it is going to ensure that the data message that we received, it is error free. That is going to detect your damage, your loss or duplication. So you can see from this figure that 3 different processes are running on each station. Suppose this is process A, it is B, and it is C. So the process of station 1, it should be received by the station 2, but by the process B only, not by A and C. This is called a process to process delivery. Network layer, it is responsible for just host to host delivery. That station 1 data, it is received by station 2. But the transport layer, it is going to ensure process to process delivery. That on that particular computer, which process it is going to receive that data, it is being ensured by this transport layer. Next, it is your session layer. Simple session layer, it is responsible for dialog control and synchronization. It was designed to, establish and maintain and synchronize the interaction between communicating systems. Next, it is your presentation layer. Presentation layer, it is responsible for your, handling the syntax and the semantics of the information. For, data translation, for compression, for encryption, for decryption. So all this done by presentation layer. And at the top, the last layer, it is called your application layer, which enables the user, whether it is a human or software, to access the network. You can see the laptop screen, you can see the smartphone screen, and you can touch it. You can feel that video. It is all possible by this application layer. So it provides, user interface and support for services such as your electronic mail, for remote file access, for file transfer, for uploading, downloading, in order to access your World Wide Web. So this application layer, it is a basis for email forwarding and storage. It allows a user to access files in a remote host, to retrieve those files from a remote computer. You are sending an email, then that mail, it is going to be stored in recipient mailbox, and whenever at any time you can access your mail. It means it has been stored somewhere. So this file transfer access, it is done by this one. And then a user can log into a remote computer and access the resources of that computer. Then accessing your World Wide Web, then directory services. So all these are the duties of your applications layer. And this is the summary of the layer. So just you can see that what we have studied in brief, they have summarized the functions of each layer. So just have a quick view of this summary of layers. So guys, Today we have studied OSI model, that is Open System Interconnect. Why we call it as open system? What are the different layers in OSI model? What is the difference between ISO and OSI? That OSI model, first it consists of a physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and last it was your application layer. And we have seen the each duties, each functions of those layer, how they do the encapsulation, how the decapsulation happen at the receiver. So this is an assignment that you have to draw and explain the OSI model with the duties, with the function of each layer. This is my email address. So it's all about today's lecture. Thank you very much.